Okay, so we're back for part 2 of lesson A2. First thing we want to do is talk about the unit vector, okay, which we'll refer to as u. We'll reserve that for the unit vector. And the unit vector has a magnitude of 1, right? So you have some vector, say that's 5, right? Then the unit would be 1. Well, maybe you know the components of this big vector, but what would be the components of the unit vector, right? If that's 1, what would be those components? No, it's not 1, 1. Can't be 1, 1, 1, 1 like that. So here is yet another formula. So basically what you do is, if you want the unit vector, is take the vector that's given to you and divide by the magnitude, right? So v divided by the magnitude of v. This means the vector, this means the magnitude of vector. So this is going to be a number here. This is going to be 2 numbers with a comma and the vector brackets divided by 1 number, the magnitude. Okay, another way to look at it is, here's your vector and you're going to multiply by 1 over v. I'm sorry, 1 over magnitude v, right? So this means the same thing. So let's try it. So here's a vector, negative 2, 3, and I want to find the unit vector, which we'll call u, right? The unit vector for that vector. Well, wait a minute. The box says that I need the vector and I need the magnitude. That's right. So first we're going to get the magnitude and then put it underneath here. We're going to divide this by the magnitude, but we don't have the magnitude. So let's get the magnitude really quick. Remember how we do that? So square root of this squared plus this squared, right? There it is. That's 4. That's 9. So that's square root of 13. I got my magnitude. So now I'm going to take this magnitude and put it under the vector, right? So divide this, right? Divide this by square root of 13, divide this by square root of 13, right? Just like the box says. The box says, the box up here says, sorry, you take 1 over your magnitude, 1 over square root of 13, times the vector. There's the vector. So now how do you multiply? Well, this times this, right? So it's kind of like dividing the whole thing by square root of 13. This part here, right? You can do this or this. You don't. I'm going step by step, but basically what it comes down to is you're dividing both the components, the a part and the b part. You're dividing by square root of 13, square root of 13, right? And as you know, we can't leave fractions with a radical on the bottom, so rationalize it, and you get 13 on the bottom, like that. Okay, if you've forgotten how to rationalize, ask me next time I see you. And if they ask for decimals, put it in the calculator, and it changes it to a decimal for you. So what did I just do? I found the unit vector. I found the unit vector for the given vector. They gave me a vector, there it is, and they asked me to find the unit vector. Right? There's the unit vector, u. Okay? Another way to express a vector, right? Another way is called a linear combination. Okay, standard unit vectors are, what if we go 1 straight across, and we'll call that I. So how many i's do you have to go across for your vector, right? And if you go 1 unit straight up, we'll call that the j vector. How many j's do you have to go up for your vector, right? And we put them together. So the component vector, we did that. That's not this one, right? The component form of the vector is with these brackets, right? Comma, and then how many across, how many up. This new way, the linear form, is, right, how many across, how many up, and then plus in the middle. Kind of looks like an algebra expression. No brackets, no comma, plus in the middle. Okay, so let's try that one. So, for example, you have a vector dE. Starts here, ends here, right? So, what do I need? Well, I need my A and B. I need my components first, right? Let's get the components. This minus this, second one minus the second one, right? That's what I did here. And I got the component form, 6, 2. Now, with that, I can change it to, this is the component form, right? A, B, with the brackets and the comma. Now I change that to the linear form, right? 6i plus 2j, 6 across plus 2 up, right? So it's just another way of expressing the vector. The component form, the linear combination form, okay? So, what if we just give you the magnitude and the direction? What that means is we give you a number, how long an arrow, how long a vector is, and which direction it's going with an angle. Did you know that from just that, you can figure out the component? Right? You can figure out how far across and how far up and down. Look at this. So if I give you how long this arrow is, and I give you the angle, then you should be able to figure out how far across, how far up. The components. How? Well, look, you have a right triangle. I give you this number, I give you this number, and you can use SOHCAHTOA to find the missing sides. So if I wanted to find A, that would be adjacent hypotenuse. That'd be cosine. There it is. Right? Cosine of the angle is equal to A adjacent over magnitude V hypotenuse. There it is. So if you're looking for A, you solve for A, and that's how you get A. Cosine, if you want how far across, the component across, this is what you do. The A number, this is what you do. Cosine of the angle times the magnitude, and you're done. How about if you want B? Well, that's opposite. So we're going to use the sine, right? The sine rule. The sine ratio. So that would be B equals sine theta times the magnitude, right? So if we give you the magnitude and the direction, you should be able to find the components A and B with these two little formulas, okay? Gee, what does that have to do with the linear form? Nothing, right? Here, I was just showing you another way to express, right? This is one way. This is another way to express a vector. Here, what I'm showing you is if I give you the vector magnitude, how in the world could you find, right, the A and B? This is how you find it. And then you can present it how? You can present it this way or this way, whichever way they ask for. Okay, let's see an example of this. And this will be the last example and we'll be done. So if V, let me cover up so we can concentrate on the top here. If V has a magnitude of 10, see, I'm giving you the magnitude. There's the magnitude of that I'm giving you, 10. And the direction of 120, that's the angle. What is the component form, right? What is the A and the B? A, comma, B with the brackets on either sides, with the vector brackets, right? Where do you start? Well, I just gave to you the, right? I just gave you the little formulas. This is how you find A. This is how you find B. So let's do A first. Right, there's V. We're looking for A and B, right? So A, what was it? It was cosine angle times the magnitude, comma. What was B? Sine of the angle times the magnitude. So I know the angle is 120. It says so. I know the magnitude is 10. I multiply that, and I get -5. Sine 120 times 10 is 5 on the calculator. The calculator will give you these. So what just happened? We started out with the magnitude, and we ended up finding, right? We didn't start with points. We didn't start with 2 points, and we found A and B. We started with just the magnitude and the angle, and we found AB. We found the components. And of course, you can express this. I didn't write it down here, but you can express this as how? -5i plus 5 square root 3j. Okay? That's it. Let me leave you with some try problems, and we can do these when I see you. So here are the try problems, 4 of them. Find the component form and magnitude. Look at your formulas from here to here. Find the unit vector. Look at the U formula, the unit formula for this one vector. It's going to be division, right? Write a linear combination with I and j. So you need a and b, and then put those numbers in front of I and j with plus in the middle, or minus, whichever comes out. And lastly, that's kind of the answer there. And lastly, just like I did, I'm giving you the magnitude and the angle, so find a component form. Okay? And we'll do the answers next time I see you in class. All right, bye-bye.